We often treat water as a constant, a substance that is, for all practical purposes, incompressible. But when you place it in the path of a specialized hydraulic piston, even the basic rules of fluid mechanics are put to the test. This specific kind of destruction has become a global obsession. Views. These machines are loud, industrial, and carry significant risk. Yet for an enormous audience, watching them operate has become a primary way to unwind after a busy day. Understanding the appeal of these videos requires looking at two very different fields: the 300-year-old physics of force multiplication and the way our brains respond to predictable destruction. The strength of a hydraulic press is rooted in Pascal's law. It states that pressure applied to an incompressible fluid in an enclosed space is transmitted equally in all directions. Here, a motor pumps hydraulic oil from a tank into a sealed cylinder. The oil acts on a large piston. Because pressure is constant, the larger surface area multiplies the input force, generating hundreds of tons of downward pressure. In a factory setting, this controlled force is used to punch, shape, and bend solid metal components for cars and appliances. This level of power comes with a high risk of injury. Professional operation requires strict adherence to safety protocols, including light barriers and easily accessible emergency stop buttons, to ensure the machine can be halted instantly. While these tools were built for precise manufacturing, the internet has found a different use for them, turning industrial power into a form of digital relaxation. The content has evolved from crushing soft items like pumpkins and crayons to testing the structural integrity of industrial materials, such as carbon fiber tubes. By using a specialized chamber, the press can reach 300 bars of pressure. This simulates the environment at the wreck of the Titanic, roughly 2 miles below the ocean surface. This brings us back to the ultimate test: water. Under normal conditions, water molecules resist being packed tighter together, making it a benchmark for things that cannot be compressed. However, at 2,000 bars of pressure, even water yields. This animated chart shows the result. The force is so great that it actually packs the molecules closer together, reducing the water's total volume by 8%. By forcing a substance as stubborn as water to shrink, the machine demonstrates a level of mechanical dominance that few other tools can replicate. Seeing the uncrushable finally give way provides a clear visual conclusion to a physical conflict. That visual conclusion is key to what psychologists call emotional release. Watching a high-powered machine destroy an object serves as a safe proxy for venting stress, allowing the viewer to experience the results of destruction without any of the real-world consequences. Social media platforms favor this content because feelings of satisfaction are highly shareable. While algorithms are known for promoting outrage, they also amplify moments of pure, uncomplicated resolution. Much of that appeal is purely sensory. There is a specific satisfaction in watching a soft, vibrant material seamlessly deform until it reaches its breaking point and squishes out the sides. This experience requires no translation or cultural background to understand. The sight of a machine overcoming a material is a universal language. For many viewers, this simple, repetitive cycle appeals to an inner child by offering a predictable outcome. In a complicated world, the press always wins. Hydraulic systems were engineered to mold the parts that build our modern world. But by providing a consistent, satisfying release, they have also become a tool for helping us navigate the stresses of living in it.